This is an interesting topic actually. Again, if you can, actually I want you guys to, not if you can, I want you guys to close your eyes. I'll be asking a few questions. And if you're able to answer it, if it's right or wrong, doesn't matter. If you're able to think and answer it, pause, think and answer it. Have some answer. Then I'll discuss the reasoning and all of that. So it will help you with your MCQ questions as well. Mainly actually. Okay, I hope you guys are ready. Now, in this topic, in this video, we are looking at how viscosity, it varies or how it's influenced by temperature and pressure. Is it influenced? First thing, are they influencing viscosity? And if so, how are they influencing? That's what we're looking at. First thing is temperature. Keep your eyes closed. Okay. As the temperature of fluid increases, the viscosity, what do you think happens? Does it decrease? Does it increase or remain the same? Viscosity decreases. Again, I repeat, temperature increase, viscosity decrease. So inversely proportional. Why do you think they are inversely proportional? Think. So let's talk about temperature. If I increase the temperature, what happens? At a molecular level, the kinetic energy of the molecule increases. Oh, sorry. This is something that you guys have studied, with your 8th or 9th grade or 10th grade, and you will be studying about this in the next chapter. But still, this is something that you guys should have known by now. So if I increase the temperature, the kinetic energy of the molecule increases, right? So this is nothing but the molecules are vibrating more. This heightened molecular motion weakens the intermolecular attraction, right? Allowing the molecules to slide past each other more easily, thus reducing the viscosity. Right? Again, I'm increasing the temperature. The molecule starts vibrating more. The intermolecular attraction, it reduces. That's the whole source of your viscosity. If that reduces, obviously your viscosity reduces. Does it make sense? Okay, let's move on. We have a formula. You just have to copy this. All this Boltzmann constant and all will be understanding in time. For now, this is a relationship. Okay, absolute temperature and everything, all of this will be understanding in the next chapter. Now, pressure. Close your eyes again. Sorry, I don't know if you guys were closing. I was showing you guys a formula. You can open your eyes. So this is a formula you'll understand better with the next chapter. Okay, for now you guys have to take my word and write down the formula. Now please close your eyes again. Let's move on to the pressure. First thing is, does pressure influence viscosity? Answer is yes. So my question to you guys is, viscosity of the liquid increases with, is it decrease or increase in pressure? It is increase in pressure. So if I increase the pressure, the viscosity increases, directly proportional. But why? Next question is why. Think about it. Think. So when pressure is applied to a liquid, the molecules are forced close together. Does it make sense? Strengthening the intermolecular attraction. This increased cohesion makes it more difficult for the molecule to slide past each other, resulting in higher viscosity. Does it make sense? Again, go back to the origin of viscosity and interlink all of this. You'll be able to understand. See, pressure and temperature and all of this are interconnected. And that interconnected aspect will be studied in the next chapter. So I have a formula for you guys. Please open your eyes. Have a look at it. So we will be looking at the formula looks weird. Yeah, there are many versions of it. So it's left to you guys, left to the textbook, honestly, on which form you guys will be looking at. Okay. Next. Oh yeah, sorry. One last thing. Close your eyes again. So till now we looked at liquid. Those two were for liquid. Now we're looking at gas. Effect of temperature on viscosity of gas. So as the temperature of the gas increases, the viscosity, what do you think happens? Decreases or increases? In this case, it increases. Open your eyes. In this case, it increases. It's a weird thing, right? So here, the viscosity decreased. and here it is increasing. Again, close your eyes. Why do you think so? Why is the viscosity of a gas going to increase when there is increase in temperature? Do you guys have your opinion? So let me read through. Viscosity of a gas arises from the diffusion of molecules between adjacent moving layer. That is diffusion. You guys understand the word diffusion, right? Movement. There's movement of molecules from one layer to the other. As the temperature rises, the kinetic energy of the molecule increases. So again, same thing. You have more energy. This leads to more vibration per se, more movement, enhancing their random motion and collision frequency. Right? They'll start. You have seen this when you boil something or steam. Right? If you keep increasing its temperature and so on and so forth, the steam you have seen how they move. It's random. So this diffuse process which governs viscosity is directly proportional to the square root of absolute temperature, leading to higher viscosity. Okay, and this would be your relationship. And effect of pressure on viscous, the viscosity of a gas is independent of, oh, sorry, I should have asked this as a question. Okay, chalo, it's independent of gas. Okay, yes. So all of this mainly will come as MCQs. They can ask you guys such a reason based question also. So yeah, lot to look at. So you can again, sorry, one more thing. The formulas might be different in different places. They express it in different ways and they use different theorem. So if you are looking at different formulas in your books, please make use of that. So not an issue. Conceptually, I've explained everything though. Now pause and you can read through.